So in this section, we're going to talk about linear regression. What is linear regression? Is basically when you have a set of data and you want to fit a line to that data. Okay? It's linear regression when you're trying to fit a line to that data. So here's some examples of linear scatter plots. So this is a set of data here with a bunch of points, and it is pretty linear, as you can see. The second one, again, is pretty linear. It's a negative one. This one is not linear. It's actually more parabolic. This one is not linear. It's actually more cubic. And this one is, it's kind of linear, but it's more exponential. So in example 1, we're just determining whether these are linear or not. The first one, yes, it does appear to be negatively linear. The second one, if we try to draw a line through it, not good, so not linear. C, if we try to draw a line through it, yeah, it's not horrible, but we could use a better representation, so not linear. And with D, again, not horrible, but we could use a better representation, so we're going to say it's not linear. So for example 2, what we're going to do is we've got a set of data here. It says it represents the apparent temperature versus the relative humidity in a room whose actual temperature is 72 degrees. So you know when you go outside in the summer and it says it's 92 degrees, but you feel like you're dying, right? And it says the actual temperature, or the temperature with the humidity, it feels like 103. Okay? So that's what it feels like, but it's not the actual temperature. Or if you're like me and you go outside in the mountains on Wednesday of this past week, and it was 52 degrees, but it felt like 38. Why? Because it was windy. So that's different with humidity. But anyway, so in this room, it is actually 72 degrees, but according to whatever the humidity is, the temperature feels higher. Okay? So we're going to start by drawing a scatter plot, a scatter diagram with this data. We're just going to plot the points. So the first point is 0, 64. And of course, I'm not going to get these on here perfectly. Well, that one's not bad. But we're just going to go through and do the best we can. The next one is at 1065. Then 2067. 30, 68, 40, 70, 50, 71, 60, 72, 70, 73, 80, 74, 90, 75, and 100, 76. Okay, so there's the scatter diagram. And what we're going to do next is we're going to use our graphing calculator to find the line of best fit. To first graph the scatter plot and then find the line of best fit. Now, unfortunately, it's not very practical for me to try to use my calculator, and I've got an old one anyway, to show you how to do this. So I've put pictures on here to do the best that we can. And I'll also probably post an example about how to do this with Desmos on your computer. So you'll have that too. So use a graphing utility to draw a scatter diagram. And I've got your directions written out here for you. Press Stat and then go over to Edit. Hit Enter. Under L1, you're going to put in your X values. Under L2, you're going to put in your Y values. As you can see, this does not match, but you get the idea. Press second stat plot, that's above the y equals button, and enter. Oh, on plot 1. So your screen might look a little bit different than this. Like I said, mine was old here when I graphed this. This is the TI-83. So if you've got an 84, you just might look a little bit different, but not much. So you want to make sure that your plot 1 is on, that you've got a scatter plot highlighted, not one of these other pictures, that their X values are under L1 and their Y values are under L2. And we usually use this little square thing to show your points. You want to also make your window fit your data. So this window is for another set of data, but for your window with this data, you want to go from at least 0, it says 0 to 100, so that'll be enough. And the scale, since we're going from 0 to 100, you wouldn't want to mark for every one. Let's go by 10. And then your Y values, it says 64 to 76, so let's do 60 to 80. And we can mark those as a scale of 5. So you would make sure your X min is 0 here. Your X max would be 100. The scale would be 10. The Y min would be 60. The Y max would be 80. And the scale would be 5. And you don't really have to worry about this. Leave it at 1. And when you graph it, you'll get the one that fits the data that we had. Again, this one's a little bit different. Next, it says, describe what happens to the apparent temperature as the relative humidity increases. So, as the relative humidity increases, what happens to the temperature? Well, it also increases. The apparent temperature increases. Okay? We'll come back to that with our calculator here in a minute. With example 3, we're just going to select 2 points and find the equation of the line between those 2 points. So for our graph, if we were to draw a line through this, that's pretty accurate, then all we want to do is pick 2 points on that line. So I'm going to pick this one and maybe this one. They need to be fairly far apart, so they'll make a good representation of the line. Like if we just pick these first 2, you can see it's going to become way too low. So you want to pick some that's pretty good representation. So let's see, what have we picked? 30, 68. Actually, I'm going to go with the ones that I've got on my paper here. That'll be easier. I used 2067 and 8074. Write the equation of the line through those 2 points. So, we've done this before. Find the slope. Subtract the y's. Over subtract the x's. And so the slope is 7 over 60 for our line. And then we're going to plug it into point slope form and solve for y to get it into slope intercept. So y minus, I'm going to just use my first point, so 67 equals the slope times x minus 20. distribute the 7 over 60. That gives us 7/3 over there. And then add 67 to both sides. And negative 7/3 plus 67 as a decimal is approximately 69.33. So the equation of the line going through the point 2067 and 8074. So let's see if I can. Oh, that was bad. That's pretty close. So that line right there is 7/60 x plus 69.33. Using the same data, how would we find the equation of the line that is the best fit for that data? Excuse me. Okay, we just found the equation of a line through the data, but the best fit line, we can use either our graphing calculator or a graphing utility online to help us. So with a graphing calculator, you're going to go back. You've already got your data in there. You're going to press Stat and go over to Highlight Calc. And then you're going to go down to where it says Line Reg. Basically, we're finding the linear regression. And again, the 84 looks a little bit different, but basically select L1, select L2. If you're using an 83, you have to go down to 1 and press second 1, I think, and then comma, second 2. For the 84, it makes it as a list, so it's a little bit different. And then Y1. Now, how do you get Y sub 1? Well, a little bit complicated. You go to vars. That stands for variables. Then highlight where it says Y variables and the first function, because that's where we've got it graphed, and hit enter. So since we've got this, what this is going to do is it's going to take our data and it's going to go ahead and graph it in our calculator for us under Y sub 1. When you hit enter, you get A and B. So A is 32.33, B is 335.33. What is that? Or that is for this particular line. Sorry. For the one that we are doing, when you go through, you should get that A is 0.0121 and B is 64.409. So that means the equation of our line for our example is y equals 0.121x plus 64.409. And if you press graph, you'll be able to see the line that goes through your points. Part C says interpret the slope. So we've already kind of done this. The slope means the apparent temperature in the room rises, for our particular case here, approximately if we take the slope 0.121 and change that to a fraction. Let's just do 0.12. Then that would be 12 over 100, or 12 degrees over 100%. So the temperature in the room rises approximately 12 degrees as the relative humidity increases by 100%. And the last part, Part D, says use the line of best fit that we've found to predict the apparent temperature when the actual temperature is 72 degrees and the relative humidity is 45%. So we're going to use our line that we found using the calculator. And we're going to plug in 45 for X. Put that in the calculator and we get 69.85. Don't forget your units. What is that? Degrees. 69.85 degrees when the relative humidity is 45%.